Let's look at how you can speed up your Node applications by using Redis, an open source in-memory data store. Let's take a common scenario in Node development. Say a user makes a request to your API or your website, which then goes and fetches the data that it needs from either your database or even an external API. Now, if they refresh the page or they make that exact same request again to your API, the exact same process is going to happen again, even if the request was the exact same. This is where Redis can really step in and help us, because on that first request there, it's going to go ahead and take the data you got back as a response from your database or API, and it stores it in memory so that on that next refresh or request, Redis can see that it was the exact same request that was being made, and instead of burdening the database again or the external API, it goes ahead and returns the data that it had saved in its cache. So taking full advantage of Redis in this way greatly increases your app's performance and can even help you reduce latency and reduce the load on your database and external APIs as well. All of this while being really easy to set up as well. But before we take a look at this though, if you like these tutorials and you want to see more, hit subscribe down there. Also, if you're looking for some really good articles on building and scaling software, subscribe to Hacking Scale newsletter. I'll leave a link to that down in the description down below. But let's jump into Redis with Node.js. So what I've got here is I've got an example application, which is actually a Hacker News clone. So what I'm doing is I'm using Express here, and then to get my information from Hacker News, I'm actually calling off to an external API. So here, I'm using an external API, but you could also be using your own database as well for where we're going to add in Redis. You can go ahead and actually get the code for this. I'll leave a link to this in the description down below, but obviously you can follow along using your own project as well. But the first step that I want to talk about is firstly how we can actually see that Redis has made an impact. To do that, I'm going to be using a tool called Artillery. Now, this is actually a testing utility that allows us to simulate loads of different interactions on our project thousands of times, so we can actually load test our projects, and we'll be able to see some real data about the latency of each request. To do this, we're actually going to install this globally, as we can use this across all of our projects, and we're going to install it using npm. So we're going to do npm install -g and then artillery like so. So once that's gone ahead and installed, we actually need to configure it. To do that, let me just minimize the terminal here, but we need a YAML file at the root level, and we're going to call this one artillery.yml. So artillery like so .yml. Now inside of here, this is where we're going to configure what tests we want to run. For me, I'm going to paste in this configuration here, but let me just quickly explain this if you need to set this up for your own project. So what we've got here is we've got the config and we're adding a target. The target is just going to be your main URL for your project. So for me, since I'm using an Express app, that's localhost 3000. Now you don't put any endpoint after this or anything, as this is just the base level 1. And then next, what we define is something called phases. And we say we have a duration of 60, which is going to be 60 seconds, and an arrival rate of 10. Now, what this is saying is we're going to hit each of our scenarios for a duration of 60 seconds with 10 per second. So this is going to create 600 requests in total, as we do that 60 times 10 there. And that's how many requests we're going to hit for our endpoint. So now we need to define the scenarios that we're actually going to run. And you can see here, we just give this a friendly name, like search Hacker News for programming content. And for that, we're going to hit our URL, which is in my application. So that's /search, and then we do that query of programming here. So we're simulating if a user went into our search box on my Hacker News clone and then searched for the topic programming here. I'm going to leave a link to Artillery's documentation if you want to explore this awesome tool some more. But for now, this should cover us for this project. So finally, we can actually run our benchmarks here. So to do that, I'm going to bring this out. Let me just clear this terminal here. So with Artillery configured, we now need to actually run our tests here. To do that, I do need to spin up my application here. So I'm going to do npm run start. And then once that's started up, the command to actually start Artillery is going to be artillery run. And then it's going to be artillery.yml. You can actually name that YML file whatever you want here. And we'll go ahead and hit run. Now what you'll see is this is going to run a load of tests, and obviously it's going to last for around 60 seconds or so. So I'll tune back in at the end here because we'll get a summary report out, and that will show us the data that we're interested in. So once that's run, you should get this summary report like I have here, and we can actually see a few things about our application here. So what we've got here is the HTTP codes 200. So 509 of them there were a success, as that's what 200 means. But we had 91 here that hit a 500 server error. So that means they failed to actually even get the data. Now this could be because maybe I've hit the rate limit on my external API. So hopefully Redis helps us out with that. Now what we can see here as well is the response times. So 234 milliseconds was the smallest response time that I had. The longest was 2,456 milliseconds. And then the average here was 1,000 2011. We could also see the 95th percentile, so this means that 95% of our requests finished within 1790 milliseconds, and then the same for the 99th percentile here, so 99% of them finished within 2104 milliseconds here. So this is here what we are aiming to improve. As I mentioned earlier, my current setup is hitting that external API each time one of these 600 requests was made, no matter the time in between them. So as you can imagine, that really isn't very efficient, especially when the search results are unlikely to change that often. So this is where we're going to add in Redis, and we can run this report at the end as well to compare the results. So for installing Redis, there's actually two parts. First, I'm going to show you how to set up a Redis server, then installing the Redis package for Node. For this first part though, I'll be using 𝗵𝗽𝗀𝗀, but you can actually run Redis on pretty much any OS you want, and you could even use a Docker container for all of this as well. So if you want to see the instructions for your operating system, I'll leave a link to the Redis documentation down in the description below. But as you can see, you can install Redis Linux, Mac OS, Windows, and then there'll also be some instructions on Docker as well. So to do this on 𝗵𝗀𝗀, we need to go ahead and use these commands here of sudo apt-get update and then sudo apt-get install Redis. So if I go back to my terminal here, let me just clear this quickly. We can do sudo apt-get update like so. And then once that's done, we can run sudo apt-get install and then Redis. So we'll wait for this to complete, and then we'll do sudo apt-get like so, install, and then Redis like this. So now that that's installed, there is another bit that we can do if we're using 𝗵𝗀𝗀, and that's to set Redis to be supervised using systemd. This setup just enables things like better process management and also proper service ordering, and it's just the recommended way if you're running this on a 𝗵𝗀𝗀 server. To do that, we need to modify the Redis config. So what we want to do is we're going to actually open this up in VS Code. So your Redis config is going to be at /etc/redis and then /redis.conf like so. Once you've done that, you should get a file that looks like this. And what you want to do is find the line here that says supervised. And what you can see here is it says that by default, Redis does not run as daemon, blah, blah. And then we have this supervised stuff here. If you don't know if your Linux distro is using systemd or upstart, you could actually change it to supervised auto. But what we want to do is comment out this line here. So for me, that's line 327. Supervised auto, we're going to change this to systemd since I'm on 𝗵𝗀𝗀 and I know it uses systemd. And we're going to go ahead and save this configuration file, and I can actually close that out there. Now you could also use nano if you wanted to change that as well. So you could do sudo nano and then /etc/redis/redis.conf. But obviously using VS Code is quite nice and easy there. Now once we've done that, we actually want to start Redis again, as we can restart it using that new configuration. For that, you want to do sudo systemctl like so, and then start and then Redis like that. And you shouldn't run into any errors there. And that should mean we are now set up with a Redis server on 𝗵𝗀𝗀. And as I said, I'll leave a link to the description down below for how you can set this up on any other operating system, or you could even use Docker. So now that we have a Redis server, we need to connect our Node application to it. And this first means that we need to install the Redis package into our project. To do that, let me again just clear the terminal here. We're just going to simply do an npm install, and then we're going to install Redis like so. So now that that's installed, we need to set it up in our application. To do that, we're going to use the entry point of our app. So something like server.js if we're using Express, for example. So I've got this server.js here. Let me just minimize the terminal here, and we need to add some code to this. So the first thing we need to do is import Redis. So I'm going to do const Redis, and that's going to equal require. And then we'll use Redis like so. And now once we've got that, we need to set up a Redis client. To do that, it's going to be const Redis client. And then here it's going to equal redis.create client like so. So once we've got create client, this is actually going to use the default port of 6379. Now you can actually test if Redis is running if you're on 𝗵𝗀𝗀 by doing redis-cli like so. And once you've got that, you should see that you hit this 1.27 new sort of command line. And then we can actually do ping as well, and it should return pong. And that's how you know that the Redis server is running on 𝗵𝗀𝗀. And there'll be various other steps as well if you set this up on a different operating system. But as you can see there, it used the default port of 6379, which is that default Redis port. So this is what it tries to look for when you just do redis.create client. It's going to look for localhost 6379. Now, if you do need to change the port, you can obviously add the numbers here, say if you're on 6555. But if you are also using an external Redis server, you can also use URL here, and then you put in your Redis URL like so. But as I said, since we were using that default configuration and our Redis server is running on our local host here, we can leave it like this. The next thing we want to do is just make sure we're connected to that Redis client now that we've defined it. To do that, we're actually going to use an inline function like so. So we're going to set this to be async like this. And then we're also going to make sure you add these brackets in here to make sure that function runs immediately. Inside of here, we're just going to add a few helper things. The first one here is just going to be Redis client, and then we're going to do .on like so. And then inside of here, what we'll say is we'll say on error, and then we'll do an inline function here using whatever that error is coming back from Redis. This here is just going to console log whatever error we have. So we'll use console.error here, and then we'll say Redis client error. And then let's put like this. So that's going to make sure that we're logging out whatever issue happened with the Redis client if this doesn't work. Hopefully we don't hit this in today's tutorial. The next one we're going to be doing is we're going to be doing Redis client.on again. And then inside of this on, we're going to do ready. So this is the one that we do want to hit as it's nice and friendly. And then inside of it, we'll just console.log, and then we'll say Redis client started like so. So as I said, what's going to happen is once the Redis client has started, we should hopefully hit this ready here, and it's just going to console log that the Redis client is started. Next thing we need to do though is we need to make sure we're connected to that Redis client. To do that, we're going to do await Redis client here, and then it's simply going to be .connect like so. And we're also going to ping that Redis client as well, as that just makes sure that we are using that Redis client and it's all set up and it's working. So we'll do a simple basic ping like that. So there we go. We've actually set up Redis on our application now, but obviously we don't have any endpoints connected to it. What I'm going to do quickly though is if I spin down the server that I ran up earlier, so this was running my project. So to do that for this demo project, you do npx pm2 and then stop server.js. And I'm doing that because I now want to run the actual dev instance. So to do that, I'm going to do npm run dev, because what we should see now is that it should log out that the Redis client has started here, as it knows that it's found the Redis client, it's connected to it, and everything's worked. We haven't hit this error case. But obviously, again, it's not storing any data in that Redis cache yet, as that's the bit that we haven't set up. So we need to add that code in now. So if I minimize my terminal, we need to find an endpoint that I'm actually going to store in the Redis cache. Now, you may not want to do this for all of your endpoints, and I'll speak a bit about this later on when to cache and the caching strategies that we have. But first, I'll show you this example. So for the code here, we're going to be changing our /search endpoint. So I showed you earlier, we had that function that calls off to that external API, but we also have this /search here, which we get our search query in. So someone goes to our project, it's /search, and then they do that queue, and then that equals, for example, programming, which is what we used in that artillery test we ran earlier. At the moment, the results, as I said, just come from this function up here of the search hacker news, which goes off and hits our API. So this means it's hitting it for all 600 times that we ran that test earlier. So we want to change this logic a little bit. So what I'm going to do first is I'm actually going to change the const results to let, as we're going to change this to let results, and then I'm going to change this to null here. Once we've got this null, we actually need to set up what is called a Redis key. So a Redis key is simply just going to have a value for it in the data store. So it's how you know essentially what piece of data relates to what query. So for us, we're going to do const key like so, and that's going to equal, I'm going to name this something like search, as that's the endpoint I'm going to hit. And then after this colon here, I'm just going to add whatever the search query was. But I'm going to make sure this is to lowercase as well. Obviously, that to lowercase there is really helpful in deduplicating our request. If, for example, they put capital P at the start of programming, or they don't capitalize anything, it's still going to use the same data, as it should be the same data. So that's why we're making it lowercase here. This will depend on your project, of course. So once we've done that, we need to check whether we actually have this key in the Redis cache, so then we can actually return that data instead of hitting our API. So to do that, what we want to do is we want to come in here and we want to say const value. So we'll do this under key, sorry. So once we've got that key here, we'll do const value here. That's going to equal to Redis await Redis client, and then .get, and then you simply put in your key like so. So what this is going to do, as I said, is going to go off, and if there is a value in the Redis cache, it's going to go ahead and store that in that value there, or value is going to be null if it's not in the cache already. So now we can do something with that. We can say if there is a value, like so, what we're going to do is we're going to go ahead and set results. Now, my results are stored in JSON, so I'm going to do json.parse, and then I'm going to do the value that we get back here. And I'm also going to go ahead and do a console.log here that says cache hit. So this response here is, as I said, we're saying if we do get a value back from our Redis client, so the data has been stored in the cache before, we're going to go ahead and then just return simply the JSON parsed result of that value that we stored in, because you'll see in a bit that when we do store something in our cache, we do JSON.stringify. So this is doing the reverse of that. And then we'll send that back as the result. So this way we've completely skipped over doing our API call, as that's been done in a previous one. But what happens when there isn't a value in that cache? So that's going to be the else clause here. So in this else clause here, what I'm going to do is I'm going to set results now, and that's going to be equal to await. And then for me, that's going to be how we're getting in our data. So this here, we're going to use the traditional method for loading in that data. So that's going to be hitting your database or hitting your external API here. So let me use the search query like so. So you can see now we're storing, or we're getting back our results, and we're setting that to literally what we've got back from the database or external API. But now we also need to add this to our cache here. So to do that, what we can do is we can say await. We're going to do Redis client here, and then we're going to do .set. And then here you want to add in your key is going to be the first value. The next value is going to be what you want to store that value as. So that's going to be JSON.stringify for me. And then for that, I'm going to store just simply the results that we set up earlier. And then we also have a couple of options that we can use for Redis. The one I'm going to use is going to be EX, and I'm going to set this to 300. What this means here is this is the expire time for our cache entry. So after 5 minutes, it's just going to consider that there isn't any value in the cache, and it's going to go ahead and refresh that data again. This just makes sure that your data isn't going stale, as obviously if you left it in the cache for ages, it would be there and then it would always return the same result, even if your API did have some new values in it, for example. So this here is saying after 5 minutes, it doesn't matter whether they hit it again with the exact same request, go ahead and refetch that data. So that makes sure, as I said, that your data isn't stale. And there's a load of different strategies for what value you should leave as the expire time here. And as I said later, I'll explore that in a bit. But now that we've got that, we're actually ready to go. Because as you can see here, just to explain this all again, what I did is I set results to null, and then I defined a key here. This key is what we use for getting our data out of the Redis cache, so how we can find what data we've stored in there. Then we do the value here, so we go ahead and try and get that key from the Redis cache. If there is a value, we simply just return the value that's come back from that Redis cache, and then we say cache hit. Otherwise, if there isn't a value, we load in our data in the traditional method using our database or external API, and then we go ahead and we save it to that Redis cache. I'm also just going to add that console.log here as well, and we'll say cache hit or cache miss for this scenario here. So we can go ahead and save that, and this means we have our search endpoint completely set up and ready to use Redis. So let's go ahead now and run that artillery test earlier, and we can see if we've made any speed improvements here. So to do that, what I'm going to do is I'm just going to close down the dev server here, and then I'm going to do npm run start to make sure my application is running with that new code. I'm going to go ahead and clear this, and then I'll do artillery again, run, and then artillery.yml like so. That's going to go ahead and run that benchmark again, and then we'll come back and compare the results. So there we go, that test has run again, and we have our summary report here. Now there's some good news. We're now getting 600, 200 codes back, which means that everything has worked. And as I said, maybe we're not hitting that rate limit on our external API anymore, as it's now using that Redis cache. The other thing to note as well is we've got a minimum response time now of 11 milliseconds, and the maximum was 1,879. And then we've got our mean down to 43 as well. What I'm going to go ahead and do is quickly copy and paste these results here, as I saved mine earlier in a text file. If I now minimize this, and then let's say I replace all of that and save it, I'm actually going to go ahead and use Git here to see what's changed. So what you can see here is we've gone from, we had 91 500 codes earlier. We've now got 600 200 status codes. Here you saw our minimum response time on the previous non-Redis version was 234 milliseconds. We've got that down to 11. We've got our maximum response time down from 2,400 milliseconds all the way down to 1,800. But the big one obviously is going to be that mean, which we've got down from 1,011 milliseconds all the way down to 43 milliseconds. So you can see there, it's an absolutely massive improvement. And the same with the 99th percentile and the 95th percentile here, massively down from what they were without Redis, because as I said, we're now caching that data. So you can see here that Redis really does work here. But now that we've seen how to set up Redis and all of its benefits here, what we need to discuss are some caching strategies. First, what we want to do is define what the goal of caching is, which is generally to have a high cache hit rate. A cache hit rate is when there's a request to your server, it can be returned by the cache, and a cache miss is the opposite, where you need to go and request that data from either your database or that external API again, as you may have seen earlier with our console log messages where I called it a cache hit and a cache miss. There's also a few other things we need to consider about the data as well. For example, if it's changing so frequently that it can't be cached, then there's no point storing it in Redis. Also, if the data isn't requested often, there's also probably not much point in caching that data, as it's going to help you save space in your cache storage if you're not caching stuff that's requested, say, once every day or something like that, as it doesn't need to be, and it shouldn't be too much of a burden on your database to load that in. Lastly, when you're caching from your database, we can use caching patterns, and these involve what's called a proactive and reactive approach. We can also combine multiple of these approaches to achieve the best results. Now, the first strategy that I want to discuss is what we actually implemented earlier, and this is called the cache aside or lazy loading strategy. And it's obviously by far the most common approach as well, as it's probably one of the easiest to set up. But as you saw in this approach when we had our application, when your application requests some data, it's going to go ahead and try hit that Redis cache first, and if the cache is hit, it's going to use the data that it has stored in the cache. If it has a cache miss, so the data wasn't in that cache, the data is going to go ahead and be fetched from the database here, and it's going to be returned to your application, so your server.js, and that's where you then go ahead and write that to the cache. So that happens the next time that it's requested, we're going to go ahead and get a cache hit that time. This approach obviously has a couple of advantages. It means the cache contains data that's actually been requested, which actually helps keep the cache size nice and effective, meaning essentially what data is being requested and being used the most is going to be in the cache. The other advantage we've seen is it's really simple to add to get those immediate gains. The only real disadvantage of this method is that there's going to be a tiny bit of overhead added to your application if there is a cache miss, because you have to go ahead and fetch that data from the database and also write it to the cache. But generally, this shouldn't be too much of an overhead. Now, the next method that we have, as I said, the last one was reactive. This one is a proactive method, and it's called write-through. This is where we write our data to the cache and the database simultaneously. So this is what you do when you're actually saving data from your server.js to your cache or to your database. So with this, when we go ahead and make a save from our application here, we're going to write it to our database and write it to our cache immediately. This means the next time the cache is requested for that data, we're just going to go ahead and get the value from the cache, and we should know that this should be up to date with the database. This is a really good method for ensuring data consistency and reducing data loss with an approach like this, but at the same time it could also slow down your request since you have to update your data in the cache as well as the database at the same time. But this approach can generally be combined with that lazy loading approach that I just showed you from earlier, and because of this, write through tends to be used where there is some data integrity required, as well as you want the database and the cache to have the exact same information at the same time. So as I said, this method here, being proactive, is very good when you're saving data from your application, as it makes sure you're updating the cache at the same time you're updating the database. So on the other side of write through though, we actually have a strategy that we call write behind. Now with write behind, what you do is you first write your data to the cache, and then obviously if there's a cache hit, the data is going to come back when you request that. But then after some amount of time, we can actually save it to the database. So say we were saving, let's say, a number like 6 into our cache here when we hit a request. This is going to go ahead and sit in the cache for a bit, but say the database here had the number stored like 1 if you were changing something. Now after, let's say, a scheduled batch job, what you can do is say after 5 minutes, go ahead and write whatever's in the cache into our database here. So they're not always going to be in sync. Now what this does is obviously you can rely on batch jobs, so it can reduce the load on your database because you can batch update all of the values in your database from your cache here. But obviously there is a big risk of data loss here if the system fails before this step has run and you do that write job, which means that some of your data in your database could be out of sync with what's in your cache. So this method is also a little bit more complex to implement, but this pattern is really useful in applications that you're doing a lot of write operations in and where the performance of those write operations is pretty critical, and also in an application where you may be able to tolerate some data loss if things go wrong, because as I said, there will be some period of time where your cache here is out of sync with your database until that scheduled batch job runs. Now, the last approach that I want to show you is actually called the refresh ahead, and it's really similar to that lazy loading one that we saw earlier. In this method, you actually essentially predict what cache entries are likely to be needed soon, and then you proactively update them before they expire or are requested. This obviously has its advantages of reducing the latency if you predict the right requests, but it's also a bit more complex, and if you do it wrong, you can actually increase the impact on the database and potentially waste resources in the cache. Therefore, this tends to be used in applications that need low latency, but also quite predictable in the data that's coming back and the pattern of data that is requested. So what you can see here is, as I said, what we'll do is we'll first, if we're requesting some data from our external store here, if there's a cache hit, it's going to use that data. But if there's a cache miss, it's going to read from the data source, and then it's going to write that to the cache in the next step. But what makes this a little bit different from that approach that we saw earlier with the lazy loading is that if there is near expiring data in this cache, we go ahead and we run a job, say when it detects that that data is nearly expiring, and it goes ahead and updates that in the cache before it's even been requested. So next time someone requests that data, it should always essentially have a cache hit with it. And you can even do some more advanced methods, as I said, of trying to actually predict what data will be requested next based on what endpoint has been hit. So there we go. Hopefully after all of this, you have a basic idea of how to add Redis to your application, as well as the various strategies you can use to begin to increase your application's performance. If you do want to use Redis with Docker and you need to Dockerize your Node application, check out this video here. Otherwise, YouTube thinks you should watch this one. As always, subscribe for more of these, and thanks for watching.